Recall that we had seen different methods of variable selection in our previous topic, linear regression. We had covered forward selection, backward selection, and mixed selection. In this topic, we will cover ridge regression and lasso regression. And dimension reduction, as we know, is a different topic altogether, so we will see it in our next module. Now the first topic is ridge regression. Ridge regularization works by introducing a penalty term to the log likelihood function. Recall that we are using maximum log likelihood function to find our coefficient in logistic regression. So we modify the maximum likelihood function and introduce a penalty term in it. The idea of imposing the penalty is to reduce or shrink the less important coefficient values near to 0. Basically, we are trying to nullify the impact of less important coefficients. Now, as you can see on the screen, this is the modified equation that penalizes for allowing to have more variables. Lambda is a penalty parameter and beta j square is the penalty term. Now it is important to note that as lambda increases, bias increases, and as lambda decreases, variance increases. So we will have to do a trade-off between bias and variance and find an optimum value of lambda. So for this purpose, we use cross-validation. Now cross-validation, sometimes also called as rotation estimation or out-of-sample testing, is a statistical method used to estimate the accuracy of machine learning models. Don't worry, we will see cross-validation in detail in our last topic of this module, that is resampling methods. For now, let's move on to the second technique of variable selection, that is lasso regression. Now, why do we need lasso regression when we already have ridge regression? Because one major drawback of ridge regression is that in the end it will contain all the variables. As penalty term can at the most shrink the coefficients to near 0, but it will not set any of them exactly equal to 0 unless lambda is equal to infinity. Now this may not be a problem for prediction accuracy, but for interpretation it could be if p is large, that is number of predictors. So this issue is overcome by lasso regression. Now in lasso regression, the only difference is that the penalty term beta square j of ridge regression has been replaced by L1 norm beta j. Now you may ask, what is L1 norm? So we don't have to go into the details of it, just understand that there are two forms of penalty, L1 norm and L2 norm. L2 norm penalty was used by ridge regression and L1 norm penalty is used by lasso regression. However, if you are very keen about it, then just Google it, you can easily understand it. But as it is not required for us, so I am skipping it. Now this penalty term also shrinks the less important coefficients, but it can even force it to be exactly equal to 0. Hence, much like other methods such as forward selection, backward selection or mixed selection that we saw previously, this will also result in lesser variables and hence would result in ease of interpretation. So that was all about ridge regression and lasso regression.